Hello, Miss.
Hello,
How are you?
I'm fine. What about you?
I'm fine as well.
Okay, let's just wait 2 minutes for Iman and then we can start. Okay.
Okay.
Also, have you revised the yesterday's stuff? Do you have any questions?
No, not really. No.
Oh, that's good. Hi, Iman.
Hi,
How are you?
I'm good. How are you?
I'm fine. Have you revised the yesterday's stuff? Do you have any questions?
No, I don't.
Okay, that's good. Now, 1 second. First, I will give you guys a question. It's based on what we learned yesterday, just for a recap, and then we can start. Okay, recap. Mm, this one. Okay, can you both please try and solve this? Same thing what we learned yesterday.
Yeah, I think I know the answer.
Okay, tell me what's the answer.
I chose D.
D. Okay, Iman, how about you?
Is it B?
B.
Yeah.
Okay, let's see. Okay, Amar, you're right. See, Iman, yesterday we learned 4 features of a good gas exchange system, right? Can you tell me any 2 features which you remember? Any two out of those four.
What, can you repeat?
Yesterday we learned 4 features of a good gas exchange system, right? And I told you to take a
Uh,
screen device.
yeah.
Do you remember any two of them? Any two.
Large surface area
Okay, that's good. Other one?
and thick skin.
Thick skin or thin skin?
Um, thin.
Thin, right? Because then only the
Mhm.
diffusion will be short, right?
Yeah.
Okay. Amar, what were the other two except for surface area and the thick and thin skin? Do you remember?
It wasn't it like what was it? No, like something potential, water potential,
No. Wait.
or high to low. I forgot.
Somewhere there, but not
Also,
exact. Okay.
diffusion. I don't know.
Large
Uh,
surface, thin wall, good ventilation with the air, and good blood supply. Okay.
did let's
Remember these?
Diffusion. Okay, yeah.
Okay. Iman, now can you tell me what will be the answer for this question? Sorry. Mm, try now after looking at those features.
Um, it will be uh, D.
D, right? That is
Yeah.
correct. Okay. Because it says which are most likely characteristics of this surface. So, of course, we need a large surface area and we need thin walls to make it more efficient or to make it a good gas exchange system. Okay. So, this was a bit of recap from yesterday's class. Today, first, we're going to look at how to investigate the difference in the inspired air and the expired air. Okay. 1 second. Now, inspired air basically means what we breathe in, inspired, okay? And expired means what we breathe out. Is that clear? What is inspired and what is expired?
Yes.
Amar?
Yes, yes.
Okay. Investigating differences in the inspired and the expired air. Inspired and expired air. So for these, I have a picture. First, we look at that picture and then we will look at the experiment. 1 second. Okay. Mm, right. Okay. Look at this picture and then I'm going to tell you guys the experiment. First, I will explain it and then I'll write the points. Okay. So, this is a simple experimental setup which we can use to investigate the difference between the inspired air and the expired air. Okay. So, what happens is when we breathe in, okay, or basically we're talking about the inspired air. When we breathe in air, it is drawn from the boiling tube A. Okay. From here, the air is drawn into our gas exchange system when we breathe in. Okay. Now, when we breathe out, air is blown into tube B. Okay. So, here we have lime water. Here we also have lime water. Now, lime water is basically clear in appearance, like water. It has a clear appearance. But when we breathe out, what do we release? Carbon dioxide, right? Now, when that carbon dioxide comes into this lime water will turn cloudy. Okay, from clear to cloudy. Then, now how do we know what happened? Now, right here in this boiling tube A, this lime water will remain clear because the carbon dioxide did not come in it. But this lime water in B, it will become cloudy because when we breathed out, carbon dioxide came in and that carbon dioxide made the lime water cloudy. That basically shows that percentage of carbon dioxide in the exhaled air or the expired air is high than the inhaled air. Do you guys understand the experiment?
Why do we use lime water?
Why do we use lime water? Okay. Mm, right, okay. This we're using lime water here and here. Why are we using it? So that we can see what is the difference between the inspired air and the expired air. Because as I told you, when we take in or when we inhale, air goes from here. Okay. So this forms the part of the inspired air. But when we breathe out, the air comes in this tube. So this is a expired air. Now, if we compare the two lime water, this initially both are clear. This is also clear. This is also clear. But when you check after like little bit of time, like 10 minutes or something, this will still remain clear. Okay, but this one it would have turned cloudy. So that basically shows us that the expired air, it had more carbon dioxide, because only when carbon dioxide comes into this lime water it will turn cloudy, otherwise it will remain clear. Do you understand?
Oh, yeah.
Just to show the difference between the inspired and the expired. We're trying to prove that the expired air, it has a high percentage of carbon dioxide compared to the inspired. Of course, you know that when we breathe out, carbon dioxide is released, right? The released, or let's say the percentage of carbon dioxide in our expired air is high. So that is what we're trying to prove through this experiment. So now do you get the purpose of using lime water?
Yes, I do.
Okay. Amar, you understand this experiment? Any questions?
Nope, it's fine.
Okay, that is good. So I will write the points for this experiment. You guys need to know it. I'll write simple points. Okay, so you guys can refer to it later. 1 second. Okay, let us write the experiment. So we could use simple experimental setup to to investigate mm, okay, difference between inspired and the expired here. Okay, now I'll write the procedure or how it works. First thing, when we breathe in, that is basically inhalation. Inhale. Okay, so air is drawn through boiling tube A. Okay, the second point, mm, sorry. Okay, when we breathe out, or exhale. Okay, exhale, air is blown into boiling tube B. Air is blown into, and you guys, like, if it is possible, or this experiment can be tried out. It is possible and you will get the result. The test tube B, the lime water in test tube B, it will turn cloudy into boiling tube B. Or you guys can try watching a video about it. They do these experiments, they show you the results, their observations. Okay. Mm, right here, lime water is basically clear. Okay. But becomes cloudy. Becomes cloudy, or you could say milky. It will look milky or milky when carbon dioxide is bubbled through it. When carbon dioxide is bubbled through it. Okay. The next point is the lime water in the tube A. I'm just going to write A will remain clear. Okay. Will remain clear, but um, lime water in B will become cloudy. Will become cloudy. Okay. And the next thing that we need to show, or what is basically what did we try to prove? Hmm. This shows that the percentage of carbon dioxide in exhaled air, which basically went in the boiling tube B, okay, is higher than the tube A or than inhaled air. That is about this experiment. Okay. Iman, Amar, both of you clear with this?
Yeah, it's clear. Emma.
Okay, Iman.
Yeah.
Okay. So now we will move to the next part. This was one of them. Just want to underline this. Okay. Moving on to the next part. That is going to be mm, difference between inspired air and the expired air. Inspired and expired air. Okay. Mm, cool. Okay. The air that is breathed in and the air that is breathed out. Okay. They both have different amount of gases in them because of the exchange that happens in the alveoli. Okay. I will show you guys one table. Mm, one second. Table. Okay. You guys see this table? Mm, okay, right. Now, see the difference between the percentage or between the composition of the inspired air and the expired air. If you see in the inspired air, we have high oxygen, and in the expired air, we have low oxygen. Why? Because some gas exchange happened in the alveoli, and some of the oxygen is absorbed by the body. It is, of course, required by our cells for the metabolism, for the respiration. So that is why the percentage of oxygen is less in the exhaled air. Okay. Carbon dioxide, if you see what we inspire is very less, but what we expire it's high. Of course, because carbon dioxide is a byproduct of respiration, right? We take in oxygen, but we release carbon dioxide from the body. So because of that, the percentage of carbon dioxide in the expired air is high compared to the inspired air. And nitrogen, of course, we're inspiring air. It is not a pure form of air which has only oxygen. Of course, there are other gases in it like nitrogen, sulfur, whatever is there in the atmospheric gases. Okay. So in the atmospheric gas, as you guys might already know, there is 78% nitrogen. Okay, so that goes into the body, but that comes back as it is because it is not required by the body. So neither do we inhale it, I mean, neither do we absorb it, nor do we remove it. It just goes in and comes back as it was. Is this table clear?
Yeah. Clear.
Iman?
Mm, yeah.
Okay. So, one thing I want to tell you guys is that you should remember these percentages. Oxygen inspire 21, expire 16. Carbon dioxide inspire 0.04, expire 4. And nitrogen is 78 and 78. It is very important to remember these percentages, the exact value, because they will give you MCQ questions and they will ask you what is the percentage. I will show you guys one question for that at the end of the class. So make sure you learn these percentages before your exam. Okay, going to the next page. Okay, so let's write a little bit of explanation for this. Okay. Mm, okay. Air that is breathed in and the air that is breathed out. Okay, that is breathed out has different amount of gases, has different amount of gases, mm, due to what's up with my handwriting? No clue. Due to the it's readable, right? You guys can understand it.
Yeah. Okay.
It's just with this pen and this iPad. Otherwise, mine is really nice. That takes place in alveoli. Okay. Mm, cool. Now, atmospheric air contains around 20 to 21 percentage of oxygen, of which we only absorb 4 to 5%, and we breathe out the remaining 16%. Okay. Normal carbon dioxide content of the air is around 0.04%, and as the carbon dioxide diffuses into the alveoli from the blood, the air which we breathe out, it contains a higher percentage, which is 4%. And there's one more point which is not given in the table. Air that we breathe out, it contains more water vapor than we breathe in. Okay. Compared to the air that we breathe in, the exhaled air has a higher percentage of water vapor in it. And also, the temperature of the exhaled air is higher than the inhaled air. Now, there is a proper reasoning for this, but you guys don't need to know it. If you still want to know it, then I will tell you guys about it tomorrow. Mm, I will write these points. Atmospheric air contains 20 to 21 percentage. One second. Okay. 20 to 21 percentage of oxygen. Okay. Of which we absorb only 4 to 5%. Okay. Mm, breathing out the remaining one. Breathing out the air containing 16% oxygen, which is the remaining part of 21. Iman, do you understand?
Yes, I do.
Okay, that is nice. Okay. Normal carbon dioxide content of air is around 0.04%. But why is it higher in the exhaled air? Because carbon dioxide diffuses into the alveoli from the blood. And oxygen, it goes from the alveoli into the blood. Okay, it's the opposite. Into the alveoli from the blood. So we breathe out air, we breathe out air containing around 4% carbon dioxide. Amar, do you understand?
Yeah, I do.
Okay, great. And then we have the last point, which is very important, okay, about the temperature and the water vapor. Air we breathe out. Make sure you guys are very clear with these 4 points. They are very frequently asked in the MCQ questions. They will not ask you the point, but they will ask you the percentages and they will ask you to compare the water vapor, the temperature. I will show you guys the questions, but before that, make sure you guys know these. Okay? Um, Water vapor. Then we breathe in. Okay? And the temperature of the exhaled air is higher than the inhaled one. Okay. Um, I hope that is clear. Okay. Now moving on to the next part. Can I move on? Is it okay? This part is clear?
Yep.
Yes, correct.
Okay. Now, the next thing we're going to talk about is investigating effects of physical activity. Physical activity on the breathing. Okay. Or you could say on the rate of breathing. It's the same thing almost. Okay. Mm, right. Now, can you guys tell me, like, um, when you exercise or when you went for jogging or whenever you did any physical activity, what happened to your breathing? Did you notice any change in it? Any one of you?
Yeah, it became faster.
It gets faster, right?
Yeah.
Iman, have you noticed that?
Yeah, it's like we take
Okay,
deeper breaths.
right. So we need to know why does that happen, and we want to know how to investigate it. Basically, let me tell you guys why does it happen, although it is not required, but it is good if you understand. Now, what happens is, for example, we do a 200-meter race, okay, in our school, for suppose. Now, when you run 200 meters, your muscles, they are contracted, right? Your leg muscles, of course, they need energy to run that fast. And the more the more we run, the more pressure on them, the more glucose they need, or the more oxygen they need, right, for respiration. So when we run fast, our body gets deprived of oxygen. We do not have, and we're not getting enough oxygen in, right? So when we don't get enough oxygen in, our body starts to respire anaerobically. You guys would have learned that before also, aerobic respiration and anaerobic respiration. Aerobic is in the presence of oxygen, anaerobic is in the absence of oxygen. We will learn this again in detail in the next chapter. Okay, so our body, it starts to respire anaerobically. Why? Because we are not getting enough oxygen when we are doing the physical activity or when we are running, right? So when it starts to respire anaerobically, or when it starts to respire without oxygen, one thing, there's a thing called, wait, let me, lac what, okay, wow, lactic acid. Okay, so when we start to respire anaerobically, this thing, lactic acid, it starts to be produced in our body, and it will start to build up. The more we respire anaerobically, more lactic acid builds up. Okay, now after I finish the race, okay, I'm sitting there, I'm taking rest. So you guys will notice that immediately after you stop the racing, the breathing won't come to normal. It will take 10 to 15 minutes. Am I right?
Yeah,
Yes,
no.
sir.
Yeah. So why does it take that 15 minutes? Because this lactic acid, it is toxic. Okay, we do not need it in our body. We want to remove it. And to remove it, we need to get more and more oxygen in our body, right? That is why we continue to respire heavily, or the rate of respiration is still high after we finish the exercise. It is just so that we can take in more oxygen, so that we can remove this. We do not need it in our body. Okay, this is also known as oxygen depth. Okay, oxygen depth. um this one, I think you guys will learn in AS. It's not there, but I'm not sure, it might be in the next chapter. So oxygen depth is created, meaning that we had less oxygen. Okay, so we respired anaerobically, lactic acid started to build up, and now we are trying to recover that depth by taking in more oxygen. Okay, because we're still breathing heavily after the exercise is over. Do you guys understand this concept, both of you?
Yes,
Iman, you understand?
Yes, I do.
So this is the reason why the rate of breathing or the depth of breathing increases. But this concept is not there in this chapter. Okay. What you guys need to know is how to investigate the effect of physical activity on breathing. So now you guys know why does the breathing increase. So it will be easier to explain this. Okay. So, exercise increases the frequency of breathing and depth of breathing. Frequency means we will take in, like, we will breathe more in a unit time. In 1 minute, for example, before my breath was 40 breath per minute. Now it might be 60 or 70. It's just a random value. Okay, so it increases the frequency and also the depth. Okay, now how can we investigate this? We can investigate by counting our breath taken during 1 minute at rest. Okay, first I sit at rest normally. Okay, and I count the number of breath I take in 1 minute. Okay, and also, I measure the average chest expansion over 5 breath using a tape measure, like an inch tape. Okay. I hold it around my chest and I measure the average chest expansion over 5 breath. Okay. Now, what I do is, after I have got this result, I got the number of breath and I got my chest expansion during 5 breath, right? Now I exercise. Okay, you need to exercise for a set amount of time, at least 3 minutes. So it could be like 4 minutes, 5 minutes, whatever. Okay, then immediately after exercising, I count my breath again in the same amount of time, that is 1 minute. Okay, and also I measure the average chest expansion for the 5 breath. What I will notice is after exercise, the number of breath per minute will also increase and chest expansion will also increase. This is because, as I told you, exercise increases the frequency of breath. Okay, so the more number of breath in this 1 minute, and also it increases the depth of breathing. Like I breathe heavily, so the chest expansion will also increase. Is that clear?
Mm, yeah.
Well,
Okay. When the meeting ends, please rejoin same link. Okay.
okay.
Mm, cool. So I will write this. How to investigate it. You guys need to know it according to the syllabus. Okay. Mm, exercise